Assalamualaikum warahmatullahi taala wabarakatuh. We continue with anionic polymerization. In ionic polymerization, if the monomer has the electron withdrawing group substituent or acceptor such as CN, COR, CONR2, then the monomer favors an anionic polymerization. So an ion is atom or group with a negative charge and an unshared pair of electrons. So it is the chain growth in which the active center added is a negative ion. We call it as an anion associated with a positive counter ion. And an ionic polymerization has a tremendous commercial importance because of its ability to control the molecular structure during the polymerization. The types of solvent are tetrahydrofuran and aliphatic, and also the aromatic hydrocarbon. The traces of water and alcohol should be avoided as this deactivate the growing chains. Solvents such as CH2Cl2 and CHCl3 lead to the termination process, and the polymerization are generally carried out at temperature below room temperature to facilitate the control of the otherwise rapid reaction and to suppress the side reaction. In ionic and cationic polymerization, there are no chain termination by combination since the growing chains, which is the macroion, repel each other electrostatically because of their similar charge. So chain termination occur only by the reaction of the growing chain end with substances such as water, alcohol, acid, and amine. And the ion produced by reaction of this substance can sometimes initiate the new chain, or we call it as the chain transfer. Also, ionic polymerization in cationic or anionic, it will produce a living polymer, which is the ionic propagation species that retain their ability to grow over extended period of time, even after complete consumption of the monomer. And also, the ionic polymerization will proceed stereospecifically, will producing the tactic polymer. Okay, for non-diene vinyl monomer with soluble and ionic initiator at low temperature, it will produce polar. The polar solvent will favor the syntactic placement. So syntactic is the arrangement of the polymer in which it is on the um, alternate structure, alternate placement, and non-polar solvent favor the isotactic placement, which is the same side of the side group. And the absence of the termination and transfer step allows living polymerization and enable the polymer with narrow molar mass distribution, well-defined functional end groups, and block copolymer to be synthesized. Now we look at the choice of the initiator in an ionic polymerization. It depends on the monomer to be polymerized, and it has classified into two groups, which are nucleophilic initiators and electron transfer. Initiators, we have covalent or ionic metal MR, for example, NaNH2, Li, C2H52, alkoxide, hydroxide, cyanide, phosphines, amines. Second one, we have the organic metal compound like N-butyllithium, which is easily soluble in hydrocarbon. Organometallic compound of the higher alkali metals have more ionic character and are generally insoluble. Example, butyllithium. We have granite compound, for example, PHMgBr, generally low melting and soluble in inert organic solvent. And the following solvent can be used are hexane, heptane, decalin benzene, toluene, tetrahydrofuran, 1,4-dioxane. And the chemical formula of a Grignard reagent can be given as the RMGX, where R is an alkyl, aryl, or the other organic compound, and X is the halogen, especially we use a Cl, bromine, or iodine. The initiator concentration must generally be between 10 to the power of -1 and 10 to the power of -4, and the temperature frequently below 20 degrees C. Raising the temperature increases the rate of polymerization but usually decreases the tacticity. care must be taken to exclude acid, water, oxygen, carbon dioxide, carbon monoxide, which can react with the initiator and also interfere with the reaction. And the suitable method is by the heterogeneous process, which is the process that can be recycle. In the presence of catalyst, the initiator is in the form of metal or alkali metal. For reaction by electron transfer, the most common initiators are free alkali metal. Free metals can be used as solution in liquid ammonia, as a solvent, or as a suspension in inert solvent. Electron transfer process involving metal donor and monomer, and the polymerization method is heterogeneous if metal is used as dispersion, and homogeneous if it is in solution. So means that the method is heterogeneous. It means that the process of polymerization involve the catalyst which is not dissolved in the reaction. Okay, the catalyst must be separated through the filtration process. We look at the sodium naphthalene. The reaction of sodium with naphthalene result in a radical ion which can be used as an initiator. See that the product for the sodium naphthalene, you produce the strong electronegative substituent with the presence of the carbon ion. And the color changes spontaneously when the polymerization of styrene is initiated by solution of naphthalene radical ion in THF. And the dark green solution turns a deep cherry red. This one is the use of the sodium naphthalene indicator in the present in the reaction with the styrene. Okay. Reactivity of the initiators. This one is the mild, and this one is the strongest one with the presence of Li or sodium. More nucleophilic initiators such as amide or alkyl carbonate ion will produce styrene and butadiene, and less nucleophilic initiators such as alkoxide, for example, aconitrium, methylvinyl ketone, MMA, weak nucleophiles such as Br and so on will for example, methylcyanocyclate. Okay. How to choose the initiator? It is depend on the monomer to be initiated. We have monomer substituent is strongly electron withdrawing, and monomer substituent is weakly electron withdrawing. For strong electron withdrawing, we need to use weak initiator. And for monomer is weakly electron withdrawing, we need to use a strong initiator. Monomer with electron withdrawing substituent. This is the example of the monomer. Okay, good monomer. Beside the vinyl compound with electron withdrawing group, MMA, butadiene, styrene, and vinyl pyridine monomer can also and ionically polymerize. This type of monomer can be polymerized by more than one type of polymerization. Okay, styrene can also be polymerized by ionically and also by using free radical and so on. Okay, this one is also example. Ring compound epoxide but not free radical version of epoxy. Okay. Reactivity trend in the monomer increasing ease of initiation. Okay, from the left to the right, it is easy to initiate this monomer by ionically. Some monomers that can be polymerized ionically. Okay, now we look at the mechanism of an ionic polymerization. So the process is follow the process in chain growth polymerization involve initiation, propagation, and termination. But in the initiation, it forms the active center called as a carbon ion. The addition of the monomer to the active center, and during the propagation, addition of active monomer to another monomer molecule. And during the termination, we have termination by chain transfer. Okay, no termination will lead to the leaving polymerization. And we also have the hydride elimination. Okay, now we look at the mechanism in the anionic polymerization. First, the formation of the nucleophile in the initiation process. Okay, this one is the structure for the butyllithium. Actually, the full version of butyllithium structure is in this form. We have CH3, CH2, 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 and Li. So CH3 here, CH2 here, CH2, and CH2 attached to it is Li. And this butyllithium structure will fall apart to form the positive and negatively butyl and ion. And Li, positive charge, is the electron donor, which act as the Lewis bases or nucleophiles. And we have the other strong nucleophile initiator, such as the sodium. So the product here is the butyllithium with negative and positively charged. We call it as the negative butyl and ion, or the carbanion. Okay, we call it as the carbanion. And it has the negative charge is on a carbon atom. Okay, this one is the negative charge is on the carbon atom, and this one is the example of the full right version of the carbon. Okay, CH3 here, CH2, CH2, and C with electron pair and together with negative charge. If you want to write in this form, it is okay, and if you want to write in this form, also can. And then during the initiation process, this one is a dissociation, and during the initiation process, you just copy down the structure of the dissociation to be reacted with the monomer, and we can see that the negatively charged of the butyl and ion will be donated to the carbon atom of the monomer, and it will form the lithium counter and ion at the end and together with the negative charge here. So how you can write this structure? You just copy the structure of the negatively charged here first, followed by the structure of the monomer without the presence of double bond. You need to draw it as the single bond. So this one is the first butyl structure, followed by CH2, CH, and don't forget to write the Li plus, like lithium counter ion. During the propagation process, repetition of the chain by addition of the monomer. So this structure, you just copy the structure from the initiation, and then it will react with the second monomer and third and so on, and n number of monomer. So how to write down the structure? Just copy this structure CH2 CH, and don't write the Li first. You after you write the structure until CH, you just copy this structure back, the monomer structure without the presence of double bond, and at the end of the structure you write down the Li plus. Okay, don't forget to put the negative signs at the carbon. Okay, if the starting reagent are pure and if the polymerization reactor is purged all of oxygen and traces of water, propagation can proceed indefinitely or until all monomer are consumed. We call it as the living polymerization. Now we look at the process of the termination. So termination must be terminated by water, oxygen, CH3OH, or carbon dioxide. So during the termination, you just copy down the structure from the propagation, okay, and then we just add the water. And the structure is you just copy the structure in front of this structure and CH, and then the hydrogen is transferred here, so you will have CH2 here. Okay, CH ni dia akan jadi CH2. Alright, so